I'm Pete Wood. I used to be a technology evangelist, but they don't like me anymore.
Okay, we're ready to roll.
We're also going to pull it behind a speedboat to see whether we can get the whole speed of the ultimate design, because ultimately we're going for distance and not speed, so we want to have a hull that actually allows us to go at a steady speed and not burn up too much battery, right?
4 knots.
5.7.
4 knots. Now let's slide. 11 kilos.
The desire to be fully autonomous on this is very difficult. So what we're doing now is, in the middle of this, we're putting a flight controller that's normally used on drones or quadcopters. Also, we connect a GPS receiver, compasses, accelerometers, gyros, and so we can have a live indication of the GPS positioning, so it can determine its orientation, it can do pitch and roll, which again is useful on the boat, because then we can actually determine our state in the sea.
So the biggest challenge so far has been that none of us really know how to build a boat. And there isn't an instruction book online for building model boats that cross the ocean.
I also have a hallway which my wife polices strictly as to what the content is, and having 2 boats in there at a time has proved contentious, but building boats in there is actually not possible.
I think we've been really lucky with facilities as well. I mean, we started off at Reading Hackspace, which we're all huge fans of, but I think after sort of 3 days, we realised we don't really have everything that we need.
We needed equipment like 3D printers and laser cutters and places to solder and jet foam into stuff, and we didn't really have anywhere up at RS. Ryan here, who's at the Advanced Hackspace here in London, he helped us on the Superman projects a few years back.
One of the unique features of the Hackspace, and one of the things that we try and encourage people to do, is iterate really rapidly around their designs. And I think that that's been something that we've seen with this project. You know, day after day after day, build new versions of something and get those prototypes tested quickly.
We've got to be able to prototype quicker. So we've taken some different approaches in printing, we've tried different materials. So all of this is PLA, so this is polylactic acid built up in layers on the 3D printer. They're prone to going wrong. It's 20 hours, you get to this point, you cry a little, and then you go back to the beginning, so you have to print it again.
We used a variety of 3D printers across the project, but when it came down to print speed, print volume and print accuracy, the Ultimaker S5 quickly became our workhorse.
It's been a bit of a godsend to the project. It's allowed us to really quickly prototype some of the more difficult parts that traditionally would have been a bit harder to print with overhangs. That's the rear of the boat, hull, whatever you want to call it. So pretty. So one of the methods we're going to use to glue the boat together is using dichloromethane mixed with PLA into a paste that we can then paint onto the boat. When it dries, it will weld the 2 parts together.
You can get injection molded propellers, but we wanted to actually create a 3D printed propeller, and to be honest, we didn't realise we were going to have so many issues when we first started this. We tried this on the first prototypes of the boat. When we started to look in more detail at the design of the propellers, that is far too steep a pitch for the speed at which the motors are going and the power that we want to get out. And you'll see that all the time we are moving to a much shallower angle on the propeller. If you look at the commercial propellers, this has got a very smooth finish. When we start to look at the 3D printed, then we have a very rough finish.
So we've tried first using ABS printed parts and polishing them by brushing some acetone on the parts to make the surface smoother.
So So during the project we had a number of challenges trying to get the foam to evenly distribute throughout the hull and not have any air bubbles. So we had to basically cut holes everywhere we could without destroying the structure and squirt in what was basically closed cell builder's foam, and that stopped the water from getting in and kept it nice and buoyant. And then we stuck the holes together using a slurry of PLA and dichloromethane, and that worked really well. We chose the channel swimming route because it was basically what we thought would be the safest route to do, because that's basically swimmers are in the water, right? So our 3D printed model boat shouldn't have been a problem.
The channel is one of the most busiest shipping lanes in the world, and this is the general sea traffic here. What's happening here, Gary? This is
A lot of boats. They go that way and that way.
yeah.
Yes, the French Coastguard have come back and have said no. We don't quite know what we're gonna do, but I'm sure we'll work something out. So yeah.